Good morning. My name is Mukesh, and today we are going to start Bernoullis theorem. So, we are going to study in this topic what is a Bernoullis principle or theorem. Okay, so let's get started. What we are going to study next. So, what is our objective? Objective is what is Bernoullis principle, and second one is what is Bernoullis principle formula. And the third one is what is Bernoulli's equation derivation. So in this concept or in this video, we will study three topics: Bernoulli's principle formula, and a Bernoulli's equation derivation. Okay. So what is Bernoulli's principle? So the Bernoulli's principle states that the total mechanical energy of the moving fluid comprising the gravitational potential energy of elevation, the energy associated with the fluid pressure, and the kinetic energy of the fluid motion remains constant. So this states our Bernoullis principle. Let's let's move on to the next topic, that is Bernoulli's principle formula. Bernoulli's principle formula. So the Bernoulli's equation formula is, what is this? This is a relation between pressure, kinetic energy, and the gravitational potential energy of a fluid in a container. So the formula for the Bernoulli's principle is given as P plus 1 by 2 rho V square plus rho G H is equals to some constant value. So this is our Bernoulli's formula. So here P means the pressure exerted by the fluid, and V is the velocity of the fluid, and rho is the density of the fluid, H is the height of the container. So Bernoulli's equation gives great insight into the balance between pressure, velocity, and elevation. Alright, so hope you understand the Bernoulli's principle formula. Let's move on to the next topic. So the next topic is Bernoulli's equation derivation. Here we will derive Bernoulli's equation, this one. So for this we have to assume, consider a pipe with varying diameter and height through which an incompressible fluid is flowing. Okay, the relation between the areas of cross section A, the flow speed V, height from the ground Y, and the pressure P at two different points 1 and 2 is given in the figure below. So let's move on to the figure. The force is given here F1 is equals to P1A from A1, and the force getting out is equals to P2A2A, and the flow is like here from here to here. Okay, so now we will going to derive the Bernoullis formula or Bernoullis equation. So for that we have to assume something. The density of the incompressible fluid remains constant at both the point. This is number one. Now the second assumption is energy of the fluid is conserved as there are no viscous forces in the fluid. This is second assumption. So we made two assumptions, right? Okay, so the therefore the work done on the fluid is given as dw f1 dx1 minus f2 dx2. Right, so we can write this f1 as p1a1 and f2 as p2a2. So after rearranging the equation, we get dw is equals to p1 dv minus p2 dv. So basically it equals to p1 minus p2 dv. Okay, now let's move further. We know that the work done on the fluid was due to conservation of gravitational force and change in kinetic energy. We know that. Okay, so let's consider first the change in kinetic energy of the fluid is given as dk half m2 v2 square minus half m1 v1 square is equals to 1 by 2 rho dv v2 square minus v1 square. Now there is a change in potential energy too. So we can write the change in potential energy as follows: du mgy2 minus mg11 is equals to rho dv gy2 minus y1. So therefore the energy equation can be expressed as dw is equals to dk plus du. dw is the change in work done, dk is the change in kinetic energy, du is the change in the conservation energy. So we can write it as from here to here and from here to here. Similarly from here we can write this one as follows. So rearranging the equation, we get P2 minus P1 half rho V2 square minus V1 square plus rho G Y2 minus Y1. So again rearranging, the equation, we get P1 plus 1 by 2 rho V1 square plus rho G Y1 is equals to P2 plus 1 by 2 rho V2 square plus rho GY2. So this is our Bernoullis equation, and this is the most valuable equation which we are going to use in our future questions in theory, in various parameters or various ways you can